been given this model aircraft engine that has got a bent crankshaft. I'm going to see if I can straighten it. It's a 20cc engine that's been partly disassembled. This is how I first saw it, with the barrel sticking out the top. The owner was struggling to work out how to dismantle it to remove the crankshaft. I think it involves getting the circlip off the gudgeon pin, removing the piston, and then that allows the connecting rod to slide towards me and come off the crank pin. So that's what I'm working towards. The loops on the circlip on the gudgeon pin can be seen there. I think I'm going to try spearing it with a dentist probe like this one, getting it in one of those ends there and trying to just work one end off at a time. If that doesn't work, I'll need 2 dentist picks to work that circlip. You can see it starts there, it goes around to there. So we'll see how we go. So I've got that circlip removed. I've damaged it a little bit. Hopefully I can straighten that out for reuse later. That's the barrel removed. You can see the transfer ports there and the exhaust port on that side. I think there's a little mark on the front here, points towards the propeller, which or towards the back, whichever way the exhaust ports dictate which way around this goes. That wasn't pushed right in because it had been pulled out, and with it pulled out, it wouldn't pass over the piston rings, pushing it back in again. So the piston was right at the bottom, as you can see the crank's right at the bottom. The piston now can float around in there side to side, and we need to look at getting that gudgeon pin out somehow. I was hoping that a strong magnet may have pulled it out. I've got a magnet, but it's slightly too big to reach there, or I'm not sure whether it's tight or whatever, but that didn't seem to have the effect I wanted. Maybe that I need to jam something up inside the gudgeon pin now to try and get it to pull back. We'll see how we go. I've got that gudgeon pin coming out. I used a cotter pin with a turned up end on it, poked that right through the cotter pin, and found that it wasn't pulling it initially, but then I've used a hot air gun on the piston, got it up to nearly 100 degrees, which is about where spit steams off the piston, which is about the temperature you get the most expansion out of aluminium. And I've pulled on that, and it's come with that little bit of heat. So a little bit of heat might be required when fitting that later. But that lets us move forward a bit now. So that's the gudgeon pin out. In the time I took that last clip, the aluminium had shrunk back enough to bind on that when it was halfway out, so I had to heat again. But now it's out, and I suspect now that I'll be able to lift the piston out if it doesn't fall out. Yeah, it's going to fall out. So with the piston out, I think the con rod will slide forward enough to come off the crank pin, and that's the battle we've had getting this apart so far. So we're progressing here. Piston's got the one piston ring on it. I don't know, by the side that's got the piston, so that's the one that's got the circlip in it still. That goes forward. I'll leave, there's no reason to take that out. I'll leave it as an indicator that it goes, that's the forward side. That's quite warm to touch at the moment, so that's why it released its gudgeon pin. That's the con rod out. I don't know whether they're the same on both ends. I know this is the big end in the scheme of things, but it looks fairly symmetrical. I might put a little scratch on that big end just so that it goes back the same way. It's probably a front and a back as well, which I haven't marked, and maybe it doesn't matter, but so that's come off the crank pin there, and that now leaves us free to remove the crankshaft, which is what we're trying to get to because it's bent. That's the wobble in the crankshaft. It's maybe not coming up on the camera very well. It's a significant kick in it, and that's what happens when you crash your model aeroplane. Now that crank will push down a certain amount there, but I suspect it's getting hung up where the actual crank's bent, and so that's another issue to deal with here, is getting that crank out, given it's got a bend in it. I was figuring it'd be better to take it out to try and straighten it rather than trying to straighten it in the crankcase. One idea I have here is to press the crank down until it jams. It's jamming over this little keyway here, which may be the weak spot, causing the weakest spot, it's where it's bent from. I'm wondering whether by heating the crankcase in this area around here, the bearing itself may come out when I push the crank forward, because it's gone back, it's jammed, and now it could come forward, and it may bring the bearing out in that process. I don't know where that gets us at that stage. That will be the bearing out. It may mean that I can put a puller on it and pull the bearing up the shaft, or pulling it over a bent shaft, which is probably not ideal, but we'll see what happens with that. That's the crankshaft out. That front bearing didn't come out after heating it, but it did seem to, for some reason, loosen up the crank a little bit more, and I was able to just tap on the end of the crank there, and it just backed its way out. The bend in the shaft as it was coming out the back end here started to rub against the outside, but it bumped past that as well. So I don't think there's any reason to remove the two crankshaft bearings. I think we'll go out and see what we can do with trying to straighten this crankshaft. I've got to make a fixture to hold this, because the bend is about there, and this is a nicely machined surface, possibly ground, and the other bearing runs about there. It's also a nice surface, so neither of those surfaces can be messed up, and the counterweight and big end bearing pin there is also can't be gripped on as such. So I'm thinking I'll measure these up. They'll be standard metric dimensions, I believe. Just zero out my calipers. And that first section's 12 millimeters. The second section will be 8 millimeters because they're standard bearing sizes. Yeah, so I'm thinking of making an aluminium mandrel that has a reamed hole here that fits nicely over that, and an 8 millimeter reamed hole up this end, which probably comes to about my thumbnail there, which is, if that area is supported, then the end of this can be sort of tapped, and then that held in the lathe, in a lathe chuck, and then this end tapped back into shape. So I'm going to take some measurements, the length here and the further length there, and make. So this is an example of the mandrel I intend to make. About a piece of aluminium, about 40 millimeters long, 12 millimeter reamed hole in this end, 8 millimeter reamed hole in the other, and a saw cut down there so that when it's in the lathe, the lathe chuck will tend to squeeze on that block and jam the crankshaft there to hold it in the lathe concentric. I'm going out and have a go at making something that looks like that now. The 40 millimeter outside diameter is not critical. It just means that it's got a bit of clearance over the counterweight section. Well, actually 40 millimeters isn't quite large enough to clear the counterweight section, but the 40 millimeter length there probably is about the length of the chuck jaw, so the counterweight could fit behind the chuck jaw. Anyway, I'll go and see if I can knock out something that looks like that. So I found a piece of stock. It's a bit over 40 millimeters long. It's only 35 millimeters diameter. It's not as big as the counterweight end of the crankshaft there. It's going to fit on the front of the crankshaft there. It'll be shortened up a little bit. And the chuck jaw will grip on this section, and the counterweight will be out the back of the chuck jaw. So I think I can make that piece work, and it's nice to just pick up a piece of scrap that doesn't require much work. I decided to have a go at printing a fixture for this crankshaft. I printed that out of PETG. It's pretty much the design that I did on the computer earlier. That's the 12mm hole, the cut in it, and the 8mm hole. We'll see whether the crank fits in that. Looks to me like the print has expanded a little bit. Not sure. We'll see what the fit up is like. Well, that's it off the printer. That's the model set up in Bamboo Studio. It took about an hour to print. I've got a 6-layer wall thickness and 30% infill, so it's fairly solid. I think it had about 45 grams of filament in it. So we'll see how it goes now with the crankshaft. So that's the 8mm section coming through quite well there. and just trying to enter the 12mm, and that's going on. That's gone right on, and it feels quite firm. The advantage of the split in the print is it's got the ability to open up a fraction. And now when that goes in the mill or in the lathe, it will squeeze tight on it. So I'll go and put that out in the lathe now and tighten the chuck up on it. Before I was working with I found a just 35mm diameter piece of aluminium, which wasn't larger than the counterweight there. And then I found my 3-jaw chuck. The bore in the middle of the chuck was only about 40mm, and this is about 42mm. This blue thing that I've printed is actually 45mm. Anyway, because the counterweight wouldn't fit right through the chuck, it couldn't, my smaller piece of aluminium on the front couldn't grip just on the jaws with the counterweight in behind the jaw. So I've got to now use my 6-jaw chuck, which has a bigger bore and 6 jaws on it, and I can now mount this forward as far as I like. The jaws on the 6-jaw chuck are about 60mm long, so they'll overhang the counterweight and should be able to work okay. But yes, I changed the chuck to the 3-jaw chuck on the lathe, then to work out that I needed to change it back. So I'll go and do that. Well, that's the bent crankshaft. It's not running perfectly through closer to the chuck, but it's a lot better than what it is there. And I believe the bend is between where I'm measuring there and the blue holder. So I'm going to give it a tap on the high spot and see whether I can reduce that run out. The high spot is when that gauge is most clockwise, and it's just after this joint in the plastic here. That's how I'm keeping track of it. Yeah, so there's the slot. It's just, and that's the high spot there. So a hit on the end here with a soft hammer on the thread there is hopefully reducing that run out each time. Again, we'll catch up where that low spot, there it is there. So it's not the low spot, it's the high spot. And if anything, it's moved around a little bit. It's somewhere there. And I'll give that a further clock. This time it's pretty much in line with that keyway. Now it's moved almost a quarter of a turn. Oh, I seem to have made it worse. I'm going to persevere. Filming it's too difficult. I've improved that run out a bit. Not good enough. I need to go back and look through the parts and see whether I can find something that screws on here so I can get a indication happening up here as to what the shaft's doing. I've got a little mark here, which is about where the high spot is. This gauge is a little bit slow reacting. I'm in gear now. The end of that shaft looks like it's running better. I don't know whether the variation on the indicator is because of the threads there. I think it may still be a little bit because of the high spot on the bent shaft. We'll see. Just winding that carriage along, which is moving the gauge up that end of the thread. So I've reset that indicator up on the edge of this hub here and giving it a spin around. Looks like there's a high spot there which is close to where that mark was. A low spot there, about 68. And a high spot there about 83, 68 to 83. 68 minus 83 is 15 hundredths of a millimeter, which is 2.5 hundredths of a millimeter is 1 thou. So 15 hundredths is 6 of those 1 thou. So it's about 6 thou out at this point, or 0.15 millimeters, but I suspect part of that is to do with this blue plastic holder not running true, and if I have that in gear and run this again, just at, you'll see that supposedly bouncing around. The end of the thread here, visually you can't detect a lot of run out in the end of that, and before I ran right along there. So I think I'm going to leave it there. I know it's significantly better. I suspect there was more than a millimeter run out, possibly 2 millimeters run out in it when it was given to me. So my technique of straightening it is partially worked, but I don't think it's accurate enough to confirm a perfect job. When I was removing the crankshaft, this counterweight has a little bit of clearance between the inside of the crankcase and the counterweight. When it was just engaged, when this shaft at the front was just engaged in this bearing, the bend in the crankshaft was causing the counterweight to hit the side of the casing here. It's not doing that now, so that is an indication that things are a bit straighter. So I'm just pressing that in it got that far by just pressing. I'll try a couple of thumbs to press it down, but yes, I thought I'd just stop and show that that's certainly better than it was when I was coming out. This is the dial indicator sitting right up next to this collet chuck here, and you'll see it's measuring a little bit of run out there. About 3/100ths. So that's about where the high spot is there at the moment. I'm going to mark that. Well, I've got this crankshaft back in. Hopefully it's straighter than it was. It's actually hard to spin up at a pace that lets you see whether there's much of a wobble in the front of it there. I've fitted that timing aluminium piece there. It's got a little magnet in it there and a Hall effect sensor that's adjustable on the front of the crankcase there. Getting the Woodruff key to fit up inside this aluminium piece was a bit of a challenge, but we got there. So I'm sure it's quite a bit straighter than it was, but as to how much it still wants to vibrate or piss around when it's running, I think it will start and run if everything else is rigged up. I haven't bothered looking at carburetors or cylinder heads or spark plugs or spark boxes or anything like that. I wasn't intending to try and get this running, but look, the piston's going up and down. It's nice and smooth. I haven't buggered the bearings. I haven't caused any problems. I've also put this plug in where the gudgeon pin is slotted in. The little circlips that hold the gudgeon pin in are it was a bit bent out of shape. I think I've bent it back into shape, and then I took the time to meticulously fit it, and it seemed to fit and seat properly, so hopefully it won't come out and gummy up the works. So I think that's the last I can do. I got to get ready to go to Perth, so I'll finish up there.
I think the blue mandrel was a fail. It wasn't running the shaft concentrically. It's shown here in the 6-jaw chuck. I put it in a 4-jaw chuck and tuned it to run more concentrically. The best result was achieved by gripping the front of the shaft using an 8mm ER32 collet. The final result is far from perfect, but it's got to be a significant improvement on how it came to me.
Up here as to what the shaft's doing.
There's got to be some fun stuff you can do in your own shed. Get out there and have a go.